Hi everyone, welcome back to Math with Mitchell, and today we're going to be talking about lines and different types of lines and how you'll see lines throughout geometry. So there's three main types of lines. The first is a line segment, next a ray, and then a line. So you may always think of a line as just starting and ending somewhere, but in geometry, a line is going to be an infinite line or going in infinite direction. So first, we'll start with line segment, which is probably what you commonly refer to as a line. But a line segment is starts at one point, and then goes to another point. And so it has a starting point and an ending point. So sometimes you'll see them labeled like A and B. A and B. And usually the notation for that will be from line, or you'll see point A, B, and then with a little line over it, indicating that it's a line segment. You'll see how the notation is different for a ray and a line. But line segment, the key thing is that it starts and ends at one point, and usually labeled A and B. Next is going to be your ray, which is going to be it's a line that starts at one point, and then let me get the fancy line tool here. Starts at one point, and then starts at one point and then goes infinitely in some direction. That it doesn't end in the other direction. So it starts at one point and it goes infinitely in the some direction. Never stops. So usually you can label that A, and then there's really no ending point. But sometimes you'll see points that are on the line labeled B, and that's how you can do the notation A, B, and then with one infinite arrow. So usually the arrows indicate infinity or infinite direction. So the notation for array is usually A to B infinite. Note that the arrow is over the B, indicating that B is on the line, but B is not infinite. B is just on the line, but the infinite direction is in direction of going from A to B. So you're going A to B, and the infinite direction is going to be where the arrow is indicates. Next and lastly is the line. Now you're probably like, what? I thought we covered line segment, but a line is infinite, like we talked about earlier, in both directions. So let me draw here a line, but is going to have also a arrow on this side too, indicating infinite in both directions. Usually the notation will be you find 2 points on the line, and so we'll just say A and B. And the key is that you have A and B, and then you have infinite arrows on both sides, indicating that both sides are infinite, and indicating that A and B are on a line segment. So that's sort of the notation and different types of lines, segments, rays, and lines are what you'll encounter in geometry. Next, now you'll work on those a little bit, but next is really where we start doing the geometry part, which is going to be perpendicular lines and parallel lines. So perpendicular lines are lines that intersect, and it intersects at a 90-degree angle. The biggest thing with this is when remember in algebra 1 where we have definition of a line of ym mx or y equals mx plus b. You'll start finding the slope of the perpendicular line. So you may have one equation, or you may be able to find this line. Say this line is y equals 2x plus 3. And you may want to find a perpendicular line or a line that's perpendicular to it. That might be one of the questions. And the key equation to use is that the slope of the perpendicular line is always going to be the negative and the reciprocal of the slope of one of the perpendicular lines. So if we're going to use this equation, me switch the notation here real quick. It's not going to be x. It's going to be m. So you can sometimes see it as m1 is going to equal m2. So basically you're going to flip it and switch the sign, and that's going to be the slope of the other perpendicular line, which is going to be this line in our example. So the answer could be, because they don't want you to find it through a point, which then that's how you would find your intercept. But your answer could look something like -1/2 x. That could be an answer to this problem. So perpendicular lines is a key form of lines that you'll work with. And parallel lines are another very key form, or another very important form of lines. And often you'll see it defined as, A, B, where there's 2 points, A, B, and C, D. You commonly define them as perpendicular lines because sometimes it may look close, or not perpendicular, parallel. Sorry. Sometimes it looks close that they're parallel, but you want to make sure that the problem indicates that they are indeed parallel. So you have the two lines here are parallel to CD, and sometimes you can put the fancy arrows here, indicating that it is a line, not a line segment. But you'll see that notation, and that's when you can know you can sort of apply the properties of parallel lines. We'll cover some more of those details later, but for now you want to know that most of the problems you're going to see have, that's not really a good line, but you'll see a line that intersects the parallel lines like this, and you'll be asked to find the angles, like angle 1, angle 2. You'll be asked to find the angles, and we'll cover some more of those properties later in another video. But parallel lines really help us figure out an angle on this side of the parallel line and an angle on that side of the parallel line, and shapes and other things like that come into play when you start messing with parallel lines. But the key thing for slope-wise, which we'll cover in this video, is that the slope of one parallel line is equal to the slope of another parallel line. The only thing that would change is the y-intercept. So two parallel lines may look like y equals 2. 2x plus 1 and y equals 2. Y equals 2x plus 3. Those would be two parallel lines. The y-intercepts are different, but the slopes are the same. Now, if the y-intercepts were the same, then those are the same line. They're not parallel, they're just the same line. So they overlap. So that could be a trick question you might see. But the biggest thing is to know that the slopes are the same, and so that indicates that they're parallel. And later we'll cover some more angles and that you can find via parallel lines. So